Hey guys, welcome back to chapter 15. I'm going to work another example from this grand finale category. And this example is going to be another one where we use the quadratic formula. So here's the problem. If we have 3 molar NO2 and it's placed in a flask, what is the concentration of our product at equilibrium? And our K value is 0.075. So go ahead and pause the video, give this one a shot, and then I'll catch up with you on the other end. All right, so we are given initial concentration, and it's asking us for equilibrium concentration. So we're going to start with our ICE table. So ICE table, initial change, equilibrium. We've got our reactant, we've got our product. So our reactant, our product. Initially, our reactant is 3 molar and no mention of our product, so we're going to assume that that's 0 molar. Okay. And they did it a slightly different way. So in this problem, they remembered the coefficient by putting the squared up there. What I've been showing is putting it right here, maybe a different color. Okay. All right, so thinking about our change value, we don't know any of the concentrations at equilibrium, so the best that we can do is put change in as an X. So we know that our product is going to go up by a value of positive. It's got to go up, it's positive, and that's going to be X. And we know our reactant's going to go down by a value of X, but because of that coefficient 2, this is going to be a 2X. So the best we can do right now is at equilibrium, this is 3 minus 2x, and this is x. Okay. All right, so to solve, we're going to take our equation for K. So K is concentration of products over concentration of reactants. And remember, that's squared. So I'm just going to plug it right in here because I'm going to need as much room as I can possibly have. So concentration of my products was X. Concentration of my reactants at equilibrium is 3 minus 2X. And my value for K is 0.075, and I forgot to square that. Just making sure you guys are paying attention. All right, so quadratic formula. We've got to get it looking like this. So ax squared plus bx plus c. Okay. Well, the first thing I'm going to do is take care of this squared on the bottom. So does FOIL mean anything to you? So FOIL is first, outer, inner, last. So another way to write this 3x squared is 3 minus 2x times 3 minus 2x. Okay. And FOILing tells me that I'm going to multiply the first numbers. Okay. So 3 times 3 is going to give me 9. Then I'm going to multiply the outer numbers. So on the outside and on the outside. So 3 times negative 2x is going to give me a negative 6x. And inner is going to be the numbers that are on the inside here. So negative 2x times 3 is another negative 6x. And last is going to be these guys that are up here last in the parentheses. So negative 2x times negative 2x is positive 4x squared. Okay. So we take this expand it out to that. And when we FOIL, this is what we get. Taking it back to some old school algebra. All right, so now that we have FOILed, and I'm just kind of running out of room, I'm just going to go ahead and erase this, and I'm going to rewrite this right here. So 9 minus 6x minus 6x plus 4x squared. Okay. All right, I can clear this up or clean this up a little bit again. So negative 6x essentially plus negative 6x. So I can combine that to be negative 12x. So just a little bit more algebra there. So minus 12x. Okay. All right, so I got to make it look like this. Okay, so I'm going to first multiply by this ginormous sentence here. So multiply that. Those cancel. Whatever I do to the left side, I also have to do to the right side. Okay, so I'm going to multiply these two together. So first, I'm going to take 9 times 0.075. So my first number is going to be 0.675. Then I'm going to multiply 0.075 by negative 12x. So 0.075 times 12 equals, so negative 0.9x. And then I'm going to take the 0.075 times that 4x squared. So it's going to be a positive. So 0.075 times 4 gives me 0.3x squared. And remember, we canceled this out, but we still have that little x left over there. So I'm going to put little x over there. Okay. So now I just have to get 0 on one side and then rearrange it a little bit. So first thing I'm going to do is move this x to the other side. So I'm going to subtract by x, subtract by x. Remember, there's kind of an implied number 1 here. So that's going to be 0.0675 minus 1.9x plus 3x squared equals 0. Okay. We're almost there. So we've got this 0 on one side. Now we just need to rearrange this. So it's x squared, x, and then nothing. So I'm going to move that 3x squared to the front. Minus 1.9x plus 0.06. Oh, no. I had an extra 0 in there. Plus 0.675 equals 0. So now we have our A, B, and C that we can plug into the calculator. So A equals 3. B equals negative 1.9, and C equals 0.675. So quadratic formula calculator, plug in your A, B, and C. I don't have that done. All right, so I pulled up my quadratic formula calculator. So here's what I'm going to plug in. So my A equals 0.3, B equals negative 1.9, C equals 0.675. All right, so plug those into my quadratic formula calculator, hit calculate, and it gives me the following answers. So x equals 5.95 and x equals 0.377. So it always spits out two values. one of these values is not going to make sense for us. So if we go back to our table, does it make sense to have the value of what, 5.95? So let's call it 6. So if I put a value of 6 in here for x, that would be 3 minus 12. So that would be negative 9. Does it make sense that the concentration of something at equilibrium is a negative number? That doesn't even make sense. Like, we don't even know what negative 9 concentration is. Like, that doesn't mean anything. Okay. So when I look forward at my x, other way. When I look forward at my x values, this one does not make sense. The only one that makes sense is the 0.377. Okay. So plug those into our ICE table. So we've got 3 minus 2 times 0.377. And then this one's just going to be 0.377. So equilibrium concentration of NO2 is going to be 0.377 times 2. 3 minus that answer. So it's going to be 2.25 molar. And equilibrium concentration of our product is just the 0.377. I hope you guys found this helpful.